Okay, so this is section 3.3, page 312. Go ahead and read problem number 1 and try to answer A, B, and C. Pause the computer right now, try it on your own, and then we'll go through it together. Okay, so here we have this, again, it's a rate. I don't know why she calls it a ratio, but it's a rate, or they. So increased distance. So if you look here, we increased by what? 60 miles. And if we go over here, so we're going up and over, and that's in 1 hour time. So that's 60 miles per hour. If we go from the second and the fourth points, so the distance here is what, 120 miles? And then over here is what, a 2 hour time period? So in both cases, it's 60 miles per hour. And actually, even if I go all the way from this point to this point, and I divide that rate, I'm going to get 60 miles per hour. All right. And so B, the points of a line, what does this rate represent? So that's 60 miles per hour. So this represents the constant speed of the car. And then it says, explain why the triangles on the graph are similar. So if you look at these triangles, they are proportional. So they're just a scaled up version of each other. So this triangle here, like if I double, then this doubles proportionally. Over here, if I make it 4 times bigger, notice the height is going to be 4 times bigger, and then the hypotenuse is going to be 4 times bigger as well. So it's just a scaled up version of the same triangle. So again, all these are proportional. All right, go ahead and read the bottom of this page, and then we will pick up at the top of the next page. Okay, so you might remember this from the past, just depending on how long ago high school was, or high school completion, or whatever. But slope, a lot of times people remember rise over run. And that's one definition. So if you have, 2 points, and you're like, okay, how far is it rising? How far is it running? That ratio is kind of the slope of that line, the steepness of that line. A definition I like better is a rate, kind of like we just did. We just found a rate, which is the change in y over the change in x. And don't let those deltas bug you. It just means the change in how the y's change and how the x change. And it's a rate, so it's like 60 miles per hour, or you make $10 per hour, or you get 30 miles per gallon. So some type of rate. I like this definition a lot. Some people remember the formula from high school, y2 minus y1 over x2 minus x1. So they kind of remember rise over run, and they remembered this one. There's some other definitions too. So let's look at the top of this thing. So grade is 1, and you see that right here. So a grade, if you go in Colorado, on the mountains, they're going to list the grade of the road. So some of you might be, well, I just see a percent. Well, remember what a percent means. It means 5 out of 100. And so then suddenly you can see the rise and you can see the run. So for example, in Colorado, if there's a 100-foot run, which would be horizontally, okay, so say that goes 100 feet from start to finish. All right, then it's going to rise 5 feet. And so that mountain is going to have that grade, or the road is going to have that grade. So usually in Colorado, they list the grade for mountain bikers and truckers, so they know how steep it is. So for example, if you have a 7% grade on a road, that would be, the definition of percent is out of 100. But notice that it's unitless, so you could pick the unit. So I could say for every 100 miles, assume it's a really long road. And again, this is rise over run. So this is your run, horizontal. There would be, oh, sorry, I said miles. Then this would rise 7 miles, and that would be how steep your road is. So grade is one thing. Another word that we use that means slope as well is pitch, like the pitch of a roof. So that's how steep your roof is. So you might, here's a house, right? And there's the roof, really steep roof, or there might be a house with kind of more of a shallow roof. All right, so again, here the rise and the run, all right? So here's your rise, so maybe this goes up 40 feet, and then the run would just be that part, so say 10 feet. Okay, so you have a rise over the run, right? And it's like the slope is 4 there. And then here you might have more shallow, right? So the rise might say be just 10 feet. And the run might be more like, say, 30 feet. So then rise over run is here. And again, notice the units are going to match, so they're going to cancel. And it's unitless. Same thing here. It's going to be, what, 4 over 1 or just 4. So this is a really steep slope for a roof or pitch, and this is more shallow. All right, so there's lots of words we use for it. It's a rate, it's rise over run, it's a grade, it's a pitch. They all kind of go with this. All right, let's look at the next example here. I'm going to pause and scooch down on this page. Okay, I had to start over a little bit, so make sure you read why we use the letter M. That was in the little yellow box up there. Again, most things were not created in the United States of America because we're such a young country, so slope wasn't created here, so we don't use S. So you can look at to why we use them. Notice again, your book does have some videos under multimedia in my math lab. So if you want to watch more professional video on this, you certainly can. They just don't do everything, which is why I'm kind of doing this. All right, so plot these points. So again, go backwards and down, go up, and again, make sure that's on the y-axis, and then over 1, 3. And so to get this slope here, we can use, we can draw the line, and we can use lots of these points because the slope is constant. It's linear. It's not changing. So for example, if I start at the bottom here, I rise 4, run 2, rise 4, run 2. So my slope is 2. Now notice if I go backwards, if you go down in math, it would be a -4. And if you go to the left in math, it would be a -2. You still get a +2 even if you start at the top point. That doesn't matter. All right, so some of you might be like, well, how do you rise negatively? Well, you have a negative number. And same thing. Now, I could use this middle point, so I could go here, rise, and run. Notice then I'm only rising 2, and I'm running 1, so my slope is still 2. And okay, I had to edit a little bit there, so hopefully things didn't get cut off in a weird way. All right, so let's go ahead and I want you to try to find the slope of this line. You can do it by graphing. That's great. But I also want you to see if you remember how to use this formula. And then I'll show you how I like change in y and change over x better. So go ahead and try to find the slope here. I'll give you a few minutes, and then we'll come back and do this together. All right, so let me here. I got some marks on here. Let's go ahead and erase that. All right, so let's go ahead and plot what? -3, negative. So go backwards 3, down 2. And what? Over 1, down -5. So my rise would be, if I start at the bottom here, rising what? I'm going up 3. And it looks like I'm going what? Backwards 4. So my slope, if I do rise over run, is going to be 3 over a -4, which we usually just write -3/4. Okay. Let's try the formula. So, and some of you haven't seen the formula ever. Some of you just haven't seen it for a really, really long time. So don't expect you to remember this. But usually we call these like x1 and y1 and y2 and, I'm sorry, here, x1 and y1. I can't even speak today. x1 and y1, and then x2 and y2, like the first ordered pair of x and y and the second ordered pair of x and y. So here, I'm going to subtract my y's in order. So I'm going to go -5 minus a -2. And be careful because this negative is not your subtraction. Then I'm going to go back to where I started from and do 1 minus a -3. Add the opposite. I get -3/4, which is the same answer. Does it really matter where you start? No, but you just have to be consistent. So if I decide, because I can name either one y1 or y2, so I could start here and then go to the other one. So if I do that, I start with my y's always, -2 minus -5. Then I'm going to start back with my x's, -3 minus 1. Add the opposite. I get 3 over a -4, which is still -3/4. So you can use that formula. One thing I want to show you, though, that you might not have ever seen in high school is this change in y over change in x. And if you're wondering why it's y over x, think about data. usually time is here and other variables are here. Now, not always. We've done some examples where that's not the case. But notice, like, if you have a line here, we usually want to know change over time. What is my weight doing as I work from home? Change over time. This could be like hours worked. The more hours I work, the more money I make. So this usually in rates like miles per hour, distance per second, we like to have timer on bottom. So again, whatever our independent variable is, we like to have that in the denominator. And so that's why it's change in y over change in x. All right, so let's go ahead here and let's do this with a chart. And you've done this before, you just didn't know it was called slope. I'm going to make my input-output chart. So here's my input, here's my output, or my independent, dependent. And I have these 2 points, -3, -2, 1, -5. And so this is more using the idea that this is a rate. Rise over run is, like on the chart, is more of a ratio. This is more of a rate idea. So if it goes from -2 degrees in Iowa to a -5, that means the temperature dropped 3 degrees. And if it goes from a -3 to a +1, it means the temperature went up by 4 degrees. So change in y over change in x, my change in y is a -3, my change in x is 4, and I still get my -3/4. I like that a little bit better. I think that students, they don't make sign errors as much. Sometimes if they use this formula, they make a lot of sign errors. So I like using this formula instead. All right, go ahead and look at the next example in the book and kind of read through there a little bit. And then I will pick up with you again on page 316, problem number 3. So read the book, try to find the slope on problems number 3, A, B. Sorry, I had to back up. I was having some issues with screens and so forth. So I'm just going to do this on a whiteboard here. So hopefully the language wasn't too choppy there. All right, so let's go ahead and try to find the slope. Let's do it with the formula. I'm going to use the xy, change in y over change of x. And so let's see, this went up by 3. This went up by 5. So looks like that my slope there is a +3/5. I could do the y2 formula, so y2 minus y1, x2 minus that one, I still get 3/5, which since there's no negatives there, if you go that direction, it's not so bad. Now, if I graph it, right, we can check to make sure it really does give us 3/5, and we can check to make sure it's a positive slope. So the nice thing is you can always graph. So I can go over 1, up 1, put a dot, and then over 6, up 4. So 1, 2, 3, 4, 5, 6. So 6, 4. And again, should be a line. And it does have positive slope. And then the other thing I can do there is I can do rise over run. So I can actually do my rise over run and make sure it gives me that 3/5 that I found. So if I don't rise 3 and run 5, from my point, then I know something's wrong. And again, I know I don't have the graph paper here, so it's not as pretty as if you did it in your book. But you have a book and you have graph paper there, so you can do it. It just was hard for me to write on that. All right, let's look at this next one here. Same thing. I'm going to do the XY chart and just do input and output, input and output. And so here this is going down by 10 and this is going up by 6. So change in y over change in x, so that would be what? -5/3 slope. And if you do the formula, you should get the same thing, -5 minus 5, 3 minus, and then that happens to be a -3. So I get double negative. So -10, 6, -5/3. All right, and then if I graph this, and I might be running close here in time, I should get the same thing, and then I should be able to do rise over run on that. So if I graph -3, 5, and then what's the other one? 3, -5. So here's kind of my line. You can see it has negative slope, right? And if you decided to do rise over run, you could do rise, and you should be rising, what, 10? But then you're running backwards a -6. So rise over run, you should still get that -5/3. All right, try C and D. They're kind of weird. There's some weird stuff going on there. And then we will pick up with the rest of this video.